Thank you very much, and welcome to my talk about the hidden challenges of one-time integrated microfrontends. I would like to present you lots of lessons learned from various projects, and I can tell you right away, not always is a microfrontend the right choice. A brief thing about my background, I'm just right now became a professor for computer science, and I can teach building web applications whole day. But before, thank you. Before, I was 11 years in IT consulting, and there I saw various projects, various different tech stacks, and my clients, they always ask me, we need a microfrontend architecture. Can you do something about it? Can you bring it alive, despite all the challenges? And as I'm very stubborn and always seeking challenges, also my sport, I try to do what I can, dove very deep into the deeps of Angular and saw what I could do to fulfill the dream of my client. But come back to the problem. Usually, many of us, we develop web applications. It could be a project to design a web application, to build some dashboards with some features like widgets, card, type-ahead search, and so on. And if the project is reasonably small enough, it's feasible that one team or maybe two teams can develop that application. We cut out the features, we detect them, we write stories, we let the team develop one by one. But what I've seen in enterprise development, usually this is not feasible at all. Because if we would do it like this, the project would take years to be finished. And if we have a big application with lots of sub-screens, lots of functionalities, usually we need many development teams. And they could be spread all over across the world. And especially for those enterprise projects, I would like a short recap why Angular is indeed a perfect choice. It's a perfect choice because it's a full, complete framework. It's not UI only, it's really complete. And ideally, you do not need so many NPM dependencies on top to make it a full framework, which makes it easy to standardize things, to have a reusable architecture, to create libraries, UI libraries, higher level component libraries that you can share in those enterprise companies across different applications. And therefore, in enterprise projects, you stumble over it quite often. But what happens now if we build an application and we have more than one development team? Let's imagine just 3 teams. This could already lead to big problems. Imagine they work together in a Scrum system and they have sprints of 2 weeks. And usually, for sure, the features are close to be finished at the last day before the sprint stops. So what happens if they develop one single-page application in one repository? They raise the pull requests against the same repo, and there might be conflicts. There might be conflicts, for example, because one of these 3 teams, they need in their feature the latest version of AG Grid. And therefore, they want to do an Angular update. And maybe another one of these feature teams is using some other dependency on top that is not so easily updatable. And then they get merge conflicts, breaking changes, and one of the teams is really unhappy what the other team just merged. And if the teams are located all over the world and the time zones don't even allow that those teams could communicate on that day, we run into a problem. Especially if it's the day before the planned release, and now the release has to be postponed by one more day. And therefore, many management people in these enterprise companies are very unhappy if we have this classic setup with one SPA and one repo, and teams would have to orchestrate dependencies and versions. They want that each of the teams can just focus on feature delivery, business feature development. And therefore, there's often the dream, let's go to microfrontends, the same way we do already for the backend. And then, ideally, all of these teams, they get their own code repository, they can work autonomously, just consider their own feature, do not even need to take care of the other code, that they might break something, and do a deployment whenever they want without any alignment of versions whatsoever. And ideally, in such an enterprise setup, there might also be some side feature that's reused across multiple apps that could be written in a legacy version, and nobody's maintaining this. And ideally, with microfrontends, we can integrate that feature as well. So the dream setup is each team has their own repository, their own pipelines, is creating some production artifact, and in the end, we have still a seamless app. So the end user should not notice that this is a composite of microfrontends, that it's really one consistent app, as if I would have developed a single-page application. And therefore, I would like to highlight the term of having an app shell, some frame, some glue, maybe also some core components like headers or sidebar navigations and so on, that needs to be thought of alongside these microfrontends. And if we want to have this runtime setup, that really anytime from production we can load a microfrontend into our app shell, there are two options. The first option that we would come up right away is module, or nowadays without Webpack, native federation. It's close to Angular standards. Yeah, close to Angular standards, and we can reuse what Angular thought of in its SPA features. We can communicate from the app shell to the microfrontends via Angular events. We can share in this dependency injection pool some global service. We have a clear hierarchy in routing, back and forth, with router for root and router for child. And it's even feasible if we started with a build time app, with build time libraries, to later on extract some of those build time libraries and make them runtime and module federated. And by theory, if you just look at the configuration of Webpack or whatever feature we use here, we could just from the syntax theoretically say, okay, we want to share certain bundles between the microfrontends and between the app shell, and we don't care about versioning. So ideally, just from the theory, we could configure version independence or version ranges and say, okay, my app shell is already at Angular 17, the microfrontends, some are still on 16, some use 18, that should work somehow. But in reality, it's really, really risky to break this. I did a lot of prototypes, and as soon as those prototypes became a certain complexity, sometimes they were not really that complex. I was just using a form and some form validation. I realized this is breaking at runtime, sometimes even on patch level. So it's really not reliable to say the same major version should work or even allow a more configuration, fine granular settings here. So it's really risky if you use module or native federation with version flexibility. So the only way, I would say, I would recommend you can use module federation, you can use native federation, is if you really ensure the app shell and all the microfrontends are using, down to the patch level, the exact same versions. And then you say in your config, you have Angular as a singleton. There's one instance of Angular, and it has to be the same version, and then you can share it. The problem here is the dream of our enterprise management to have independent combinations, because every team should be free to pick the version, is gone. We have to have version equality even at minor level. And there are only two ways to achieve this. Either we have a strict governance, we schedule in the teams some tickets. This sprint, we are going to update to exact this and that version, and only then it can work. Or we force the teams, they have to work in a mono repository where there's one package JSON that's ruling the global source of truth, which version is currently used. So the conclusion here is you can use module or native federation, but please dare, if you want to use different versions. You can enforce this by monorepos or governance, or we can do something else than module federation. We can wrap our components into web components. So that's the second option for runtime integrated microfrontends. We can encapsulate our distinct microfrontends, our Angular apps, in a web component wrapper, and now all of a sudden, we can mix and match Angular versions. And not only Angular, we can have a React framework, some widget from a third-party company. We just bought in some special widget we can add here. And this architecture solution for microfrontends using web component is really solving the strong organizational requirement to be capable to mix and match any Angular version, any version of third-party dependencies, so we can have multiple AG Grid versions, multiple RxJS versions, and so on. And all the microfrontends can be developed in separate repositories, and they don't have to communicate to the app shell core team what they are going to use. They can just install it in their own dependencies, and it's fine. A short recap. If we talk about web components, usually with web components, we mean a whole set of vanilla APIs, but the most common one we are referring to is actually custom elements. So we can wrap any application in a custom HTML tag and inject this anywhere, in plain HTML or in an existing single-page application. And Angular is really cool here, because we have, for many, many versions, the package Angular elements. And all we need to do is install via npm or yarn this sub-package of Angular and tweak a few files in our existing code. So if we go to our app module, we can say we want to have a custom element. We can define our whole Angular app, so the root node, the root component, is becoming a custom element right now. But we could also pick any inner components of an existing Angular application and make them custom elements, make them web components that we could easily plug and play anywhere. And the magic underneath is really in this line of injector injection, that Angular Elements is taking care that all the dependencies needed for our component, all the services, HTTP interceptors, every magic behind is included, and we just need to say we want to use our component and make it a custom element, and then we are free to use it in HTML, and just make sure we load from the remote URL the bundle that's containing the logic to bootstrap our custom element to make it alive. And once more, I made many, many prototypes up to big applications using that approach. and indeed, I could not break it anymore. So on runtime, on production, I mixed and matched Angular versions, multiple major version differences, and it was all stable. It was working fine, and no problems occurred. There's one exception. One exception which unluckily was required in our application is if the microfrontends are not just what I call widget, so a single screen representation of something, but actually inside the microfrontends there was routing involved. So sub-pages with certain sub-URLs. And the problem here is now, with this web component architecture type, we have multiple instances of Angular's router module for root. And this was never an intention of Angular. This was never taken care of. We really, with this approach, are leaving the intention of Angular, intended to be a singleton with this router knowing the whole truth, what's going on in our browser window. And Angular is intended to build SPAs with one version of the framework and has this very good hierarchy in these routers between libraries and shells. And Angular also has a lot of complexity inside this router module. So if we would just look at the API, there's so much inside, and we are breaking this by this approach. But my customer was not happy. He still wanted to have that architecture, no matter what. So I tried to figure out what was causing these runtime exceptions. What's happening right here? Why did it break? So I checked the Angular router from the inside and tried to figure out what is happening. And let's recap traditional websites. So not single-page application, but old-school websites connected via hyperlinks. So what do? When they navigate from one URL to another one, they change the window location directly. The problem is that browsers detect, okay, this property, my global window location was changed. Now I have to reload HTML, start from a blank screen, load the HTML, load the referenced CSS and JavaScript, and build everything up from scratch. And this means also that all in-memory state is gone. And single-page applications, not only Angular, but also the other ones, they use a trick. They use a trick to prevent that the browser is loading from right screen everything again. They indirectly manipulate the window location via the window history. So it works basically like a time machine. They pretend the URL we are navigating to is where we already are. And the URL we were before, yeah, it's just changed in the history. So in the browser back, it's treated like the previously visited screen. And by this whole right screen loading is prevented, and everything seems very smooth. The problem is, this is a secret to the Angular router instance. So the Angular router is keeping track that this was happening and knows its state. If we use one, everything is perfect, because Angular is fully capable dealing with that. But the problem now is if we have more than one Angular instance, and all these microfrontends and the shell, they all manipulate this browser history in silence, all together at the same time, we end up in race conditions. Because there's no event telling globally in the browser that window history got manipulated. So we can end up browser back not working. We can end up the state in the microfrontend does not reflect our URL. We see some different screen. And we can even end up in a vicious cycle of URL changes and our browser is dying. So we can break it really easily with such. And there are some ways out, for example, also on Manfred's blog, how to solve it on a top-level thing. So if you can have a convention and say you use the shell only to navigate into a microfrontend, and then you let your microfrontend do all the sub-navigation inside, you can have some base path prefix convention router matcher and say, okay, as soon as we reached microfrontend 1 as a top-level URL, microfrontend 1 is in charge. Same for microfrontend 2. The problem here is it's then no longer in control of the app shell, and the MFEs are in charge, and our customers still had the dream that we get some safety from shell level, and that we have deep linking. So really, we wanted to navigate from the app shell, from some navigation widgets, whatever, anywhere. So directly jump, for example, having Microfrontend 1 loaded already from page 1 to page 2. And if we do this via a router link in the app shell, we trigger a router event and change the URL indirectly to page 2. The shell knows where we are. Shell could highlight the correct visited screen in a sidebar navigation or header, but the problem is the microfrontend itself, Microfrontend 1, would not know that the URL has changed. It would still believe we are on the old screen on page 1 and show the wrong content, because it has no technical choice at all to know that the URL got manipulated. And what we can do now is try to patch this problem. There's only one fundamental technical problem. This is that there's no detectable event that we manipulated our browser URL. And we could think of creating manually a URL changed event. And we have multiple native options to do that. For example, we can have custom events alongside a DOM element as the event bus, or we could use the broadcast channel API. And just as a short snippet how that would look like, we have the shell. Maybe the shell manipulated the URL. It sends an event, and the microfrontend can listen to it. The main difference between these two APIs is custom elements are bound to one DOM element in one screen. Therefore, they are bound to one browser tab. The broadcast channel API, on the other hand, is synchronizing across multiple browser tabs, multiple browser windows, and also across iframes. And if you think about creating such a custom patch for this URL communication, you have an architectural challenge, because you have to define standards in your enterprise company. What do I use? Which type of event bus do I use? What is the event format? So you could use these cloud event JSON base template format to form your events, but still there are some degrees of freedom, because the topic, the type, is just a string. And you would have to make sure that across all the microfrontends and the app shell, and maybe multiple app shells, if you want to exchange microfrontends, have to have the exact same string as the type in order to make something work. And yeah, how can we patch now exactly this URL problem? Let's go to the flow. We have our browser. It has the window location as the source of truth for the URL. We are currently at Microfrontend 1, page 1. Now in the app shell, we are triggering a rerouting to page 2, and this indirectly changes the URL in the browser. The Microfrontend 1 would still believe we are at the old page. And now the actual trick sending this patched event is using the Angular router mechanism again. So we hook into on navigation end event of the Angular router and make sure if we manipulate the URL and on navigation end, we inform everyone else living with us in the same browser window and sending an event via the agreed API, via the agreed conventional topic, and then others can listen and synchronize. So this is the only way we can have a stable implementation of multiple router Angular instances in one browser. And this is the leanest way because we can reuse the Angular router. We don't have to replace the router. The Microfrontends can still use the router. The app shell can still use the router. We just make sure to inform when we do something in secret. And by this, really, we made a big application which went live on production, and everything was stable. You could reload screens, you could do browser back, you could navigate back and forth, instantiate deep links from bookmarks. Everything was fine. But still, my conclusion is not always is a fully isolated microfrontend in forms of a web component the recommended choice. If it's a smaller project, it's not 20, 30 streams across the globe you cannot orchestrate, I would try to stay with Angular if we can, work in a mono repository, and if you need runtime integration, extract some modules via federation. One thing where still web components are a super valid choice is if you want to have microfrontends without routing. Because without routing, there are no problems, and compatibility between versions is really not a problem. And only in this super, super complex scenario where really this isolation of web components is needed due to versioning, and still we want to have routing, there is a way, but it has to be treated with lots of caution to have this custom router solution with these patched events. And be sure you have architectural thoughts about this API, because there is no universal API existing. You would have to come up with some standards. How shall it look like? Which event bus has to be used? How should the events be named? What kind of events do I send? What is the duty of the app shell? What are the MFEs allowed to do or not? So there are many, many degrees of freedom. So please consider, if you want to do something like this, it has to be treated with care. Thank you for listening.